Thinking of code as instructions, what if we want our instructions to repeat themselves, i.e. do this until this, do this 5 times, and so on? There is a way we can do this in Python, and that's what we're going to be looking at this session. They're called loops. As the name suggests, loops are flow of control statements that can direct a block of code to run, that is, be looped through, multiple times. In Python we have 2 types, for and while, and we're going to explore both. While loops. Put very simply, a while loop is like an if statement, only where if statements run either once or not at all, a while loop can run as many times as you need to, so long as its condition remains true. Here's an example of a program that uses a while loop. See how it's structured in the exact same way as the ifs we looked at last time. That is, keyword, condition, body. It also works the same way, at least at first. If the condition is met, we enter into and execute the body. The difference comes when we exit out of the body at the end of the block. Where an if statement will just continue on with the rest of the code, a while loop will actually go back and reevaluate that the condition is still true. If it is still true, the block runs again, then again, and again, and again, until finally the condition evaluates to false, at which point we continue on with the program, never looking back. Let's walk through this example. T starts with a value of 10. The condition of the while loop is t is greater than 0. T is greater than 0, so this statement is true, and the condition is met. We enter into the block of code. See how the last line of the body reassigns t to be 1 less than its original value, so 9. Once we reach the end of the body, we check the condition again. T is now 9. 9 is still greater than 0, so the condition is true, and we go again. And we keep going, counting down t until we reach t equals 0. 0 is not greater than 0, so this condition is false, and we exit out of the body. Can a while loop go on forever? Indeed we can. There are a few cases for while loops that are, or at least could be, infinite. It's generally something we want to avoid, as it could cause our problems to get stuck, never moving on from that loop. With the previous example, we knew what we were doing. We knew that we were starting at 10, we remembered to decrease it by 1 each time, so we knew we'd eventually reach t equals 0 and exit out of the loop. But depending on what we're trying to do and what condition we're trying to meet, and crucially what happens inside of the loop each time, we might not be so lucky. This is why we need to take care when using while loops, otherwise our program might get stuck. But we can, if we're feeling mischievous, do it deliberately to see what happens. For fun, here's an example of the infamous while true loop. Usually what happens is it really does just keep going until something forces it to stop. This could be you, for instance, by closing a window or pressing stop on your editor. Most of the time this is fine. Sometimes it can even be very useful for things like servers or background tasks, but depending on what it is we're doing, how long it's been going on, and how many resources that loop is taking up, and crucially, whether or not that amount is growing, it can be a problem. Usually, what happens is that it really does just keep going until something forces it to stop. This could be you by closing a window, this could be pressing stop on your editor, this could even be your OS stepping in and forcing the process to stop. Most of the time this is fine. Sometimes it can actually be very useful for things like servers or background tasks, but depending on what the while loop is doing, how long it's been going on, and how many resources it's taking up, and crucially whether or not that amount is starting to grow, it can be a problem. For loops. For loops are a little bit different. They're also our first example of a statement that needs 2 keywords. For loops rely on some collection of items to work. In the context of a for loop, we call this an iterable. That is something that gives us multiple elements to iterate through. The for loop will run once for each of those elements. Remember our collection data types like lists. These are great examples of iterables. Let's see this in action. Here we have a list of names that we're going to iterate through, which we've stored in the variable members. We then open up a for loop, starting with the for keyword, and then a new variable name, then the in keyword, then the name of our collection, or our iterable. This list has 3 elements, so the for loop runs 3 times. Simple enough. Where it gets interesting is the variable item. This is what we call the loop, or iteration variable, a special variable that is defined automatically at the start of the for loop, and takes the value of each element in the iterable one at a time. For this example, see how item takes on the value of every name in the list, starting from the 0th. We can also iterate through tuples, sets, dictionaries in much the same way. The name of the loop variable doesn't actually matter too much. Some common names include item, element, and I, but as long as it's a valid variable name and doesn't conflict with anything else, you can pick pretty much whatever you want. Just remember, like any other variable, it's advisable to pick a name that makes sense to you and will still make sense when you look at your code again, not having seen it for a month. For the above example, member, name, or even person would have all been perfectly sensible choices, but maybe not X, or thing, or derf. That's it. Just 2 different kinds of loops, for and while. But before we wrap up, there are a couple of fun features that Python has built in. There are also examples of what we call syntactic sugar. That is, features of a language that don't add anything new, don't make anything possible that wouldn't have been possible without them, but make the code easier to write and easier to read. Computer scientists often like food metaphors, so we use the metaphor that it makes the code sweeter for the human writing and the human reading it. Computer scientists often like food metaphors, so we use the metaphor that it makes the code sweeter for the human writing it and reading it. The first of these extra keywords is the continue keyword. Remember that loops, by their nature, can run multiple times. We call each one of these runs an iteration. So, for example, this loop here will have 5 iterations, 1 for each element in my list. When a program encounters a continue statement, it exits whatever iteration it was in early, and moves on to the next one. Here we can see that the number 3 just doesn't get printed. This is syntactic sugar because it would have been possible anyway. We could have just wrapped the entire body of the for loop inside of an if statement, if number is not 3, but writing it with a continue keyword makes it a little bit nicer, a little bit sweeter. This is syntactic sugar because it would have been completely possible anyway. We could have just wrapped the entire body of the for loop inside of an if statement, if number is not 3. But writing it with the continue keyword makes it a little bit nicer to read and a little bit nicer to write. Next up is break. If you like, you can think of break as being like super continue. That is, it not only skips over whatever iteration you're currently in, but all subsequent ones as well, exiting, or breaking out of, the whole loop early. See here, no number after 2 gets printed. Break statements can be super useful in the while true loops we hinted at earlier, i.e. keep doing this forever until one of however many specific conditions is met. A good example of this is games, where you might want to keep rendering the frames forever until the user actually says, no, stop, quit. Finally, a brief word on loop variables. Did you know we can have for loops with multiple loop variables? They look like this. 2 variables, 2 different names, comma separated. This doesn't work all the time. Most of the time it just wouldn't make sense. We're only interested in 1 element at a time after all. But there are a few exceptions. The only one we're likely to need in this course is when iterating through dictionary items. Remember, we said dictionaries contain pairs of keys and values. By default, when we go through a dictionary with a for loop, we only get the keys. But by using this .items method, we can go through both at once. Here's what it looks like. we have a dictionary which maps the members of a band to the instruments they play. Members.items will iterate through every key value pair in the dictionary, of which there are 4. We can see that each pair gets unpacked to 2 loop variables, which we've called key and value, which we can then reference separately in the body of the for loop. When we run it, we get this. There are other use cases for this feature. However, the dictionary key value pair is by far the most common. Learning about how it works and where we can use it elsewhere can be super interesting if you're curious and want to know more, but it's by no means essential. Summary. With this, we've got the fundamentals of flow of control covered. We can go beyond thinking of our code as just line by line, top to bottom, step by step, and start thinking of it as more dynamic and flexible. Already, we have a toolkit to start tackling some simple, potentially even some quite complicated problems and build solutions. Or at least we will do once we take the time to strengthen what we've learned and our understanding of it.